Okay, so let's have a look at this question here. You should have a copy of it. There's a couple extras here if you're missing. A block rests on a horizontal surface and has a mass of 45 kilograms. Force is applied to the block and has a magnitude of 142 newtons. The force is directed upward at an angle. The block begins to move once the angle gets to 60 degrees. So if we draw the diagram, we're going to see an applied force like this of 142. We're going to have an angle of 60 degrees. We're going to have a weight force down. We're going to have a normal force up. Now remember, of that 142, part of it is vertical and part of that is horizontal. Those are the horizontal and vertical components. And this block is going to move to the right, which means our friction is going to be backwards like this. Okay, so that's sort of all your forces that are on the object. The block begins to move once the angle gets to 60. Now that is code. It's code for the horizontal force is now equal to the friction force. Okay? There's enough horizontal force to overcome friction force. I mean, some might argue, okay, the horizontal force would be slightly more than the friction force. Okay? Generally what happens is because there's static and kinetic friction, there's a coefficient of static friction, you need a little bit more horizontal force to get it moving. Once you get it moving, then you need less. Okay? So we're going to assume that the horizontal force is equal to the friction force. Now getting that horizontal force is relatively simple. The question actually is, what's the coefficient of friction, right? And that's going to be mu equals FF over Fn. So I have to get my FF and I have to get my Fn. And FF is going to be equal to my FH. So FF is equal to FH, which is going to be 142 cos 60. So that is 71. 71 newtons is my friction force. So now the next step is to try to figure out what the normal force is. Now the normal force generally is equal to the weight force. But in this case here, because I'm lifting up, the weight force sort of, the vertical component and the normal component, those two things balanced by the weight force. And in fact, I showed a few people this the other day where I said vertically the net force is 0, which means that I've got normal force plus weight force plus vertical component. Those are the three vertical forces, right? The Fn, the Fw, and the Fv. And together they have to add up to 0. How come? Because the average isn't going to go up or down. Right? It's not going to accelerate up or down. So now let's fill in what we know. Now we don't know the weight force yet, do we? So I got to squeeze that in here somewhere. 45 times 9.8. $441. Okay, so now let's fill in here. I've got 0 equals the normal force is what I'm solving for. My weight force, because it's down, is going to be minus 441. And my vertical component, oh, I don't have that yet either, do I? You're going to be mad at me. FV is going to be 142 sine 60, 71. Okay, now I'm in good shape. So now I've got my vertical component. Now it's up, so that's going to be plus 71. Okay? Yeah. Thank you. 123. Well, it's, you know, the first of the month, so I'm allowed a new mistake. 123. So now my Fn, I'm going to take the 123 and I'm going to take it to the other side. I'm going to take my 441, I can't do that, and take it to the other side, right? And so I'm going to get, normal force is going to be 441 minus 123. Let's see if I can rewrite that actually legibly. So that's going to be how much? 318. 318 is my normal force, and now I can go mu equals Ff over Fn. Friction force is my 71. Normal force is my 318. And I get a frictional coefficient of 0.223. Okay, let's go move on to part B. So now in part B, what I should do here is, part B it says the coefficient of kinetic friction is 0.1, so it drops down to 0.1. Determine the time required to move 1 meter once it begins to move. So we are going to try and solve for t, given that my d is 1 and my kinetic friction is 0.1. So before I can get to, you should have a basic understanding that at some point you're going to have to go through F equals ma, because F equals ma is the formula that bridges from forces to acceleration, which means you can go to velocity and distance and time, right? That's the key one. Okay, so we got to get F equals ma. The m we know, the F is the net force. So redrawing our diagram, my force of 142 remains the same. My horizontal component of 71 and 123 remains the same. But because the mu value changes to 0.1, then my friction value is going to change as well. You ladies need to watch, so you do get this.
I do get it. I answered the
Okay.
question.
Okay. Does Carly? Okay. The weight force and the normal force are going to remain the same, right? So the key idea is to figure out what the new FF is. So it's going to be mu equals FF over Fn. The mu value has dropped to 0.1. My FF is my unknown. My normal force is the same one as before, which was that 318 value, which gives me a friction force I can do in my head, 31.8. And now that I've got my friction force, now I can solve for F net. It's going to be my horizontal component plus my friction. It's going to be 71 and then minus 31.8. 39.2. Taking my net force, F net equals ma. 39.2. The mass was 45, giving me an acceleration of 0.871. And then it's a simple matter of using the kinematics equation VIT plus 1/2 AD squared. What do you know? Another formula. Hard to believe. We're looking for time? Aren't we all looking for just a little more time? No. 1 meter. Initial velocity is 0. 1/2 the acceleration of 0.871 t squared. You guys can do the math. 1.52 seconds. All right, the next one, we've got a 25 kilogram, 2.5 kilogram block. The inclined plane is 25 degrees, and Justin, I can't find this one. At the bottom, the velocity here is 0.65. And the incline is, this distance is 1.6 meters. And the question is, what is the acceleration? What is the coefficient of friction? And does either result from A or B depend upon the block's mass? Okay, so to find the acceleration, we got the mass, I got the distance, I've got the incline, and I've got my final velocity. How am I going to find the acceleration? Oh, I know the initial velocity, don't I? 0. I think you're right. Vf squared equals Vi squared plus 2AD will give us the acceleration, I believe. So the final velocity is 0.65. The initial velocity is 0. 2A in my distance, I should have made 1, but I didn't. 1.6. Solving that gives you an acceleration of 0.13. Do you get the feeling that the next part's harder?
No.
No? What should I do, Nicole? Anytime you've got a block on a ramp, you should always find the FD and the FN. You're going to need them, right? And I'm going to allot some marks for that. So that's a good strategy, is to go ahead. You said FN, right?
Yes.
And that's mu. No, it's not. It's mg cos theta, right? Mg cos theta. Okay, let's go with that. So my block was 2.5. 2.5 times 9.8 times the cosine of 25. $22.2. And we should find the FD as well, because the FD is actually what's causing it to accelerate, right? That's mg sine theta. 2.5, 9.8, sine 25. Is it 10.35? I'm reading someone else's answer here. 10.35? Okay, so let's just put those in here. So I've got FD there, I've got FF there. Before I can go from acceleration, my mu value is FF over Fn. Does it say anything about a constant? Oh no, it's not a constant velocity, it's an accelerated velocity, isn't it? I got to find my FF. Okay? My net force is the sum. The net force that causes this 0.13 is the difference between the FD and the FF. Like there was no friction, the net force would be FD, but there is friction, so the F net is the difference between FD and FF. Okay.
Do you use tan theta equals FF over Fn?
All right, so what I'm going to do is I'm going to go F net is equal to FD plus FF. The F net, oh, I don't have that yet, do I? I've only got my acceleration. So here's what I'm going to do. I'm going to drag that over there, and I'm going to write F net equals, big sigh from the crowd. Mass was 2.5, acceleration was 0.13. I get a net force of 0.325, is that right?
Yeah.
Okay, so now if I've got 10 newtons of force down the plane, but my net force is only 0.325, that means my friction is quite a bit, doesn't it? Right? The net force is my 0.325. The FD is my 10.35, and my friction is going to be, well, I'm just going to write plus FF. Goes to the other side, becomes negative. You get negative 10.03, roughly. Okay, on the home stretch now, mu equals FF over Fn. The friction force is 10.03. The normal force was this value here, 22.2. Giving me a relatively high, really high value of 0.45 for my coefficient of friction. There's a lot of friction here. Okay, now Nicole wants to know if we could use tan theta is equal to FF over Fn. Actually, isn't tan theta equal to mu? FD over Fn? No.
Not for FF, but
Yeah.
it's the same answer that you got for FD.
Is it? Well, you're telling me when you go tan 25 FF over the number here, 22.2, you get an FF of just 10.35. Okay. That's because this is only true when it's frictionless.
Okay.
Right? This is only true when it's frictionless. Which is, yeah.
Okay.
Okay? So no. In short, no. All right, now part C says, does either result from A or B depend upon the block's mass? Now we use the mass over and over and over again, but does it really matter? I'm going to need a new page here. Let me just show you. Okay? Well, yes, I know it's just a yes or no answer, Chris. Did I use acceleration here, or did I use the mass in the acceleration? No, so obviously not there. When I go mu equals FF over Fn, let's do a little bit of formula manipulation here. My FF, right, was really my Fnet minus my Fd, right? And my Fn, I'll just leave like that. And my Fnet was mass times acceleration. My Fd is mg sine theta. And my Fn was mg cos theta. And if I factor out an m on top, I get a minus g sine theta. And on the bottom, I've got mg cos theta. And guess what happens? So does the mass matter? No. Even though I used it, I multiplied by and then I divided by, I basically cancel out. Okay, so the answer is no, the mass of this object doesn't matter. No, I'm just pointing this out. But you should be able to do this. This is the kind of stuff you're going to see next year, and they're going to just like whip through in about 30 seconds and expect you to be able to follow it.